Hey everyone, Mr. Anderson here. In Chapter 4 of our Common Core Algebra textbook from CPM, we're going to start Chapter 4, and Chapter 4 is all about solving equations, specifically solving systems of equations, solving equations that contain more than one variable, and to do that we need more than one equation. How can we do this? This is a little bit more complex, but we're still going to build off of some of those skills that we learned in some of the prior chapters in this course. And today we're going to get started here with section 4.1, question 4-1, and we're going to go ahead and make the translation from the written story or situation into the equation. And you can see in my notes here, that's exactly what I've got going on. And this, for some students, is the most difficult part of your traditional algebra course. It's how do we take the situation that I have over here on the right-hand side, 1, 2, 3, and 4, and turn it into the equation in A, B, C, and D. And that's what I'm going to do. And I'm going to use process of elimination and some terminology and tools that we have, and we're going to see if we can nail this down. I'll start with number 1 right here, and that's this guy. It says a zoo has 2 fewer elephants than zebras and 5 times more monkeys than elephants. The total number of elephants, monkeys, and zebras is 30. Well, I know a couple things about this. I know things like 2 fewer means, hey, take away 2. That's a Q for me. 5 times means I'm going to multiply by 5. All right, and then of course I see the total number of elephants, monkeys, and zebras is 30. When I hear total language, I'm thinking equals 30. So what I'm doing is I'm looking for an equation that probably has 3 pieces and a total equal to 30. Well, shocking, these are all equal to 30, so that maybe isn't the best help. But there's one equation here that has 3 parts. Check this out. I've got, in letter C, I've got a part there. I've got a part there, my second term, and I've got a third term, a part there. And each one of those things represents elephants, monkeys, and zebras. Okay, check it out, right? 2 fewer elephants than zebras. If Z is my zebras, then there's 2 fewer. Okay, and then 5 times more monkeys than elephants. Well, there's 5 times more than that. So check this out, ladies and gentlemen. Number 1 is going to link successfully with letter C. Let's move on to the second question. Zola earned $30 by working 2 hours and receiving a $12 bonus. Well, again, we're going to use some cues here. One more time, there's equals 30. And she did work 2 hours, okay? And I don't necessarily, how to put it, I don't know necessarily what her rate is right now, but we could do some thinking on that. But what I do know is that earnings is equal to the rate of pay times the number of hours that she worked. In this case, the number of hours she's working is 2. And then you're going to multiply by some rate of pay. And actually, I'm not going to use R there because I realized that all the equations include Z. So maybe I'll go with Z. And then, of course, a $12 bonus means that somebody added on $12 to her total, right? So that's going to, in that case, be something like A, right? We've got this narrowed down. Okay. Moving on to number 3, 30 ounces of metal is created by mixing zinc together with silver. The number of ounces of silver needed is 12 times the number of ounces of zinc. 30 ounces of metal. Again, there you go. That's going to be equal 30, right? Sometimes we don't catch that. Be careful because that's a written number right there. It's spelled out THIRTY versus just a 3 and a 0. And then we've got mixing zinc and silver. In this case, that and, or zinc with silver, I could translate that, means I'm going to be adding those. The number of ounces of zinc is 12 times. So I'm looking for a multiplication by 12, and I see that right here in that particular problem, right? Letter D, I'm sorry, I see that written in the equation in letter D. And then in this particular case, I already know by process of elimination, oops, sorry about that. I already know by process of elimination that B and 4 are going to go together, but let's look at why. Eddie earns $5 an hour, worked 2 hours longer than Zach, who earns $12 per hour. Together they earn 30. Well, here's my equals 30, right? Together they earned 30 bucks. But Eddie is earning $5 an hour, so $5 times his rate. Well, Zach earns 12. So here's Zach's rate of pay, 12Z. and Eddie is earning $5, but he worked 2 hours longer. That's going to be Zach's hours and then 2 more. Okay? And that, of course, is unfortunately multiplied by 5. Eddie makes less money than Zach, apparently. All right, we're going to keep on keeping on, and you guys, this will be if it's not making a ton of sense, I'm sorry, if it's not making complete sense now, this is going to be one of those things that we continue to develop throughout our unit. But if you're totally lost, this might be one of those things that we've got to be willing to practice, B, be willing to reach out to our teacher for some help on, try a couple things and ask some questions. 4-2 does have us kind of moving into this space here a little bit further. 4-2 talks about all these mathematical sentences or all these equations that we have over here on the left-hand side of 4-1. They're easier to understand when everyone knows what the variables represent. Remember, folks, this is one of the biggest barriers that we encounter in mathematics is the communication barrier. And you want to make it blatantly clear exactly what each thing is referring to. So, for example, they give us a thing, a definition here, and it's in blue, and you guys can click on that in your text here. But a statement that describes what the variable represents is called a let statement. Okay, so if we were back on up to A and we connected A to letter C, what would Z be? Well, we could go ahead and we could talk about, A connected to, I said C. A connected to 2, my bad. It's this connection right here. Sorry about that, folks. 2Z plus 12 equals 30. What does Z represent? Well, if you look at their let statement, Z represents Zola's rate of pay. Okay, so Zola got paid for 2 hours worth, Z times 2, and then she got the $12 bonus. That makes her $30 total. We're going to practice one more let statement here, but we're going to write a let statement for B. And I did this already. And in B, we connected B to number 4, the one that we just talked about, Eddie and Zach working together. Eddie's hours were based on Zach's hours because Eddie worked 2 hours longer. So Z represents in this particular case the number of hours that Zach worked. So I would write, and I did, let Z represent the number of hours that Zach works, okay, or worked. And one of the things we always want to make sure that let statements include is units of measurements, because units are important in the case that if we have a unit error, we could be communicating totally different things. For example, if my units were in degrees Fahrenheit versus degrees Celsius, right, could be a big deal. 0 degrees Fahrenheit is different than, 30 degrees Fahrenheit is different than 30 degrees Celsius. 32 degrees Fahrenheit is, of course, our freezing cutoff. 32 degrees Celsius is shorts weather, right? So just, be careful. All right, let's move on to number 3. And in number 3, we've got a problem, and I'll spend a little bit more time. In fact, I'll spend the bulk of the video on this one. We've got something I'll slow down a bit on, and it focuses on something we all have familiarity with, and that is a triangle. We know that we've got a perimeter of a triangle, and that perimeter is 31 centimeters. Sides 1 and 2 have equal length, while side 3 is 1 centimeter shorter than twice the length of side 2. Twice the length of side 1, excuse me. Let's determine how long each side is. Well, they start this problem by saying, hey, let X represent the length of side 1. And then they ask, what is the essential part of this let statement that's missing? Okay, and I answered that already, and maybe you caught this, maybe you beat me to it. The let statement is, of course, missing the unit, right? What's that unit? Well, we should have centimeters. Let X centimeters represent the length of side 1. Now, we don't always write those in equations because we don't want to jumble up our equations. Our equations are mathematical shorthand intended to help us solve, okay? But now, what are the lengths of side 2 and side 3? I'm going to remind you that sides 1 and 2 have equal length. So if side 1 is X units, or X centimeters, excuse me, side 2 is going to be X centimeters. All right. Side 3, though, is 1 centimeter shorter than twice. Well, 1 centimeter shorter than means we're taking away 1. All right. if my brother is 1 centimeter shorter than I am, I'll take my height and subtract 1. Now, it's not just x minus 1, because it's 1 centimeter shorter than twice, right? Twice is that word that means 2 times. Okay, so it's going to be 2 times x and 1. Okay, that's going to be my statement, my expression, in fact, for side 3. Part B says write a mathematical sentence that states the perimeter is 31. Well, remember, the perimeter is going to be my total side lengths of that triangle specifically. So I'll write my mathematical sentence, and my mathematical sentence in this case is going to be an equation. So I can take x and 2x and 1, and I can set that equal to 31. Now, if you stop here, that's fine, but we want to communicate these things effectively mathematically. I've got side 1, side 2, and I've got side 3. Let's use some prior knowledge. Let's combine our like terms. We can put all those x's together. X, and 2x makes 4x minus 1, and that's equal to, 31. Okay, there's my equation, 4x minus 1 equals 31. And here we go. Part C says solve the equation you found in part B. So we're going to take this thing right here and we're going to do some solving and determine the length of each side. Be sure to label your answer in appropriate units. All right, here we go, folks. We've got 4x minus 1 equals 31 in our direction, say to solve. Well, this should be the short part, and then we're going to go ahead and interpret what this means and figure out how we can check and so on and so forth. I added 1 to both sides, and I've got 4x. This is equal to 32 now, right? Because 31 and 1 make 32. I'll divide now by 4, and quickly we get x equals 8. Now, don't stop there. Let's take it a step further. Let's say specifically x equals 8 centimeters, right? We've got a label there, right? And there's the labeling, and we'll talk about this in terms of, and I'm trying to draw a triangle with 2 sides equal and one side that is noticeably longer than the other, right? And I think that is going to work out. If this is side 1 at 8 and this is side 2 at 8, now we can go ahead and we can figure out if side 3 is going to work out here. Real quick, if I know that x is 8 centimeters, then check this out way back up here, ladies and gentlemen. What's 2 times 8, right? I'm plugging in, by the way, 8 for x. 2 times 8 minus 1. 2 times 8 is 16. Minus 1 is, of course, 15. That's 15. Okay, so there's my triangle. Side 1, side 2, and side 3. How can I be sure that I'm spot on correct? Well, let's ask ourselves this question. Does the P for perimeter, equal 31? Well, verify with me, please. What's 8 plus 8 plus 15? Because after all, that's all perimeter is, right? Oops. That's all perimeter is distance around that triangle. 8 and 8 and 15, of course, does add up to 31. So that's how we can check our answer there, ladies and gentlemen. If you need to pause that, back that up, go ahead and rewatch if necessary. But there is just a small amount of relevant review preview here at the end of this for you, right? Recall this review preview is in our CPM ebook. You can click on 411 and scroll to the bottom where you see that magical review preview logo, and then start to knock out numbers 8, 9, 10, and 11 and 12, right? Oh, I'm sorry, ladies and gents. I made a bit of a mistake here. Skip 411. Okay, 4, 8, 9, 10, and 12. Ladies and gentlemen, thanks for watching. Have a great day.